So welcome to talk number 8, which is about the possibility of possibly being able to make some kind of spacecraft that uses anti-gravity or the ability to manipulate gravity or circumvent it to power or hover a spacecraft. In this talk, I'm going to just go into some ideas which are possibly bonkers and make no apologies for just exploring ideas that I think are interesting or fun. So the idea of things that can hover or fly have been around in science fiction and in movies for decades. They're almost just like this sort of staple thing of like when you encounter an advanced civilization anywhere in science fiction, they just naturally have like things that hover. I think it's interesting to compare that to just the idea of flight in general, which baffled humans for hundreds, if not thousands of years. At some point, a couple of hundred years ago, somebody did some calculations and concluded that humans would definitely not be able to fly and that it absolutely wasn't physically possible. And then some people came and did it. So I'm going to explore the idea that maybe the aliens who visit from Mars in Doctor Who with their spacecraft that just hovered in midair might one day be possible. And this also links into the idea of sort of warping space and space-time. And as you'll see, the idea of sort of defying gravity and doing some kind of space warp are not entirely unconnected. So first, I'm going to go through a sort of brief history of gravity and our theory of gravity and our understanding of it. So Isaac Newton was the first person, or is at least credited with the idea that all objects attract each other. So he came up with this equation in the top left, which is that the force attracting two objects is some number g, which just gives the strength of it, multiplied by the mass of one object and the mass of the other object divided by the distance between them squared. And then when you combine that with force is mass times acceleration, you can then work out how much those objects will accelerate towards each other based on their masses and the distance between them. And that was just a totally new idea. People before just thought that stuff fell to Earth because that way is down. And he was like, no, it's not down, it's just everything in the universe attracts everything else. So that kind of blew people's minds, and his equations of gravity, as well as his equations of forces and conservation of momentum, are still taught in school today and have changed physics forever. This diagram of his idea of gravity as per said equation. So then I think about roughly 200 years after that, the mathematician called Gauss came up with these ideas of curvature and the idea of intrinsic curvature and extrinsic curvature. So this is, on the left is a diagram of a piece of paper, a flat two-dimensional surface with a triangle drawn on it. And Gauss said that if you curve that piece of paper is extrinsically curved, as in if you look at it from the outside, it's curved. But if you are an ant living on that surface, that triangle still has angles that add up to 180 degrees, and the lines on it are still straight, as in to get from one corner of the triangle to the other, you still go along the shortest distance between 2 points. So the lines are still straight in as much as they are the shortest distance between 2 points. So although the paper is extrinsically curved, intrinsically, it's what he still called flat, because two-dimensional geometry still works. Triangles still have angles that add up to 180 degrees. So he said that that surface is still flat. But if you look at the surface of a sphere, like the Earth, that the surface of that is not flat. So it's both extrinsically curved, but it's also intrinsically curved. And you can see that if you were to imagine yourself starting at the North Pole and walking in a straight along the surface line, shortest distance, down to the equator. And at the equator, you then were to turn 90 degrees to the left and then walk along the equator a quarter of the way around the Earth, which might take a while. And then when you've walked a quarter of the way around, you turn 90 degrees left again. You walk back up to the North Pole again in a straight line. And when you get to the North Pole at the top, you turn 90 degrees left and you are back to where you started. So you have done 3 90-degree turns and walked 3 straight lines. So you have drawn out a triangle, but the angles in your triangle add up to 270 degrees, not 180. So the two-dimensional surface of the Earth is not flat. And this was his idea of intrinsic curvature of two-dimensional surfaces. Gauss had a student called Riemann. Oh, sorry, forgot about this slide. So on a sphere, the surface has positive curvature. Then on a cylinder, that surface is flat. And then on a sort of toroid, the surface has like negative curvature. It's like the opposite of a sphere. So two-dimensional surfaces can be intrinsically curved one way or the other. So Gauss had a student called Riemann, and Gauss said to Riemann, hey, I've got this idea about this two-dimensional curvature. Can you extend it to 3 dimensions to give the idea of space, like 3-dimensional space, but the 3-dimensional space is curved? So Riemann did a whole load of maths. He did all kinds of maths to do with geometry, and he eventually came up with a set of equations that let you calculate and work with the idea of 3-dimensional space being intrinsically curved. And he did that maths, and it sort of sat on a shelf for a while until Einstein came along. And a bit like Newton with his idea of gravity, Einstein revolutionized the idea of gravity by saying that the gravitational field is space itself, and that when that field curves, it's actually space itself being curved. And somebody introduced Einstein to the work of Riemann with his geometry maths of 3-dimensional curved spaces. And Einstein gave it a go to see if he could make it work with his theory of gravity. And he couldn't, so he gave up and he went and tried something else. And then that didn't work either. And then he came back to it and he tried again. And eventually he managed to make it work. And he combined this idea of 3-dimensional curved space with the 4th dimension, which we talked about in previous talks, of time. And so Einstein said that space-time curves and that is what gravity is. And so he created this idea of general relativity. And general relativity says that a mass bends space-time, and therefore, essentially, when you are in a gravitational field, i.e. you are in an area of curved space-time, or a volume of curved space-time, that you have to accelerate in order to stay still. So if you imagine yourself standing on the Earth, there is the force of the ground pushing up on your feet. And according to Newton's equations, force equals mass times acceleration. If you've got a force pushing up on your feet, you should be accelerating, but you're not. Newton said you're not because there's an equal force of gravity pulling you down. And Einstein said, no, there isn't. There is no force of gravity pulling you down. It's just that space-time is curved towards the Earth, and therefore the force pushing up on your feet is accelerating you, but because you're in curved space-time, you have to be accelerating in order to stand still. And everyone went, what? And then people did lots and lots of experiments and realized that he appears to be right. And he appears to be right because if I press the right buttons, if you go back to this theory of gravity from Isaac Newton that says that there is a force between two objects, you can do a bunch of calculations and you can work out things such as the orbit of Mercury around the sun. And it turns out that the answer you come out with is not quite right. But if you take Einstein's view that space-time is curved, you get a very slightly different answer, which turns out to match reality. And this happens in the orbit of Mercury. If you use Einstein's calculations to give you a slightly different answer, you get the correct orbit of Mercury. And because he says that space-time is curved, it also gives you the result that time slows down when you are closer to a large mass. So time in the atomic clock in a satellite runs faster than the same atomic clock when it's on Earth. And people have tested this, put satellites into space. People have even accidentally put satellites into egg-shaped orbits, because there's one particular case where one of the rocket boosters broke, and so the satellite just went into this elliptical orbit, and people went, oh, that's unfortunate, but it gives us a great opportunity to test how time changes as the satellite gets closer to Earth and further away from Earth in its weird shaped orbit, and it all matches Einstein's equations perfectly. So this guy is Dr. Grahame Blackwell, who I talked about in a previous talk with his theory that all matter is photons wrapped into 3D structures. And he published a paper, which I don't have the date of. He published a paper a few years ago, which essentially says that if you take the idea that like charges repel and opposite charges attract, as with electric charges, a negatively charged electron attracts a positively charged proton, and two electrons will repel each other, or two protons will repel each other. He said, if you take that idea, but you take the idea that the attractive force between opposite charges is very, very, very slightly greater than the repulsive force between like charges, and you sort of work that out for every single atom in a large mass based on its distance from every single atom in another large mass, that actually you don't end up with Isaac Newton's simple equation. He says that you actually end up with the same Riemann equations that Einstein used in general relativity. So in that diagram from Isaac Newton's thing, which I'll go back to because it's useful to look at it, Isaac Newton's theory of gravity measures the distance between two masses as the distance between their centers. So when you want to measure the force of gravity between the Earth and the Moon, you measure it between the center of the Earth and the center of the Moon. And that roughly works for most people's use cases. But this guy says that actually, if you take the assumption that the attractive force is just very, very slightly greater than the negative force, and you don't work it out from the object centers, you sort of do some calculus to work it out as if it's acting between every atom of one and every atom of the other, you end up with the same maths as general relativity, except the relative bit, which, as we again discussed in an earlier talk, can be explained in other ways. So this, I think, is really interesting because, as with special relativity and time dilation and object contraction that we talked about in earlier talks, we saw that you can arrive at the same set of equations via a different fundamental theory. And this says that you can arrive at the same set of equations as general relativity, but without having to assume that there is space-time or that space-time is curved. You can arrive at the same set of equations through a different theory. And that, I think, is interesting because it opens up other possibilities. General relativity can be correct, but it can be correct for the wrong reasons or for the wrong underlying theory. So my own thoughts on anti-gravity are that there are potentially three possible ways or three possible types of anti-gravity, not three ways of doing it, but three potential types of what I would consider anti-gravity. So the first type is what I would call gravity cloaking. So if we are to assume that gravity is some kind of electromagnetic wave, then scientists have now developed ways of cloaking things from sound waves. You could potentially cloak yourself from gravitational waves. So if you're a roadrunner on Earth and you then stick a cloak around yourself, you could then isolate yourself from the gravitational waves, and you would then just float off into space due to the lack of centripetal force holding you onto the Earth as it spins. Although I redid that animation because technically, if you're spinning around the Earth and the centripetal force disappears, you'll actually fly off parallel to the tangent. But that's essentially type one. You cloak yourself from gravity so that you don't experience its force. Type two is the idea that for every reaction, there is an equal and opposite reaction. In other words, if you send a bullet one way, the gun comes back to you the other way. And this is one of Isaac Newton's equations, the conservation of momentum. You push one thing one way, something else has to go the other way. And this happens in normal gravity, in that when you jump off a high wall and you come down to Earth, the Earth also comes up to you. The Earth doesn't come up to you very much because it's vastly more massive than you are. But essentially, in order for you to come one way, the Earth has to come the opposite way. And the same when you jump up off the Earth, you push yourself upwards, but you push the Earth down. So type two of anti-gravity would be essentially the literal opposite of normal gravity, which is that rather than two objects being pulled together, they are pushed apart. So you would sort of propel yourself away from the Earth by pushing the Earth backwards, but using gravity or some kind of gravitational wave or force that literally just acts in the opposite way that normal gravity does. The third type is what I would describe as space swimming, which is that if you are just out in the middle of space with no large mass, no planet, no star to push yourself away from, that you are somehow able to just move yourself through space without having anything to push yourself off against. So you essentially just sort of, if if space or the ether or whatever is like water, you're just able to somehow swim through it without having to push anything back in the other direction other than space itself. So those are what I see as the three varieties of how anti-gravity would look if it ever existed. Might any of them be possible? Well, the cloaking thing, based on the idea that gravity might be an electromagnetic phenomenon, scientists have actually done quite a lot of work using metamaterials to be able to cloak things from electromagnetic waves. So metamaterials are sort of materials or several materials put together in a certain structure that allow that material to manipulate electromagnetic waves in a way that a single substance wouldn't be able to do. And metamaterials often look a bit like this. And using these, scientists have managed to create a form of cloaking, and they have actually managed to cloak something from microwaves. Oh yeah, the James Bond car. So scientists have basically managed to make something that, if it was in the visible light spectrum, it would give you something vaguely approaching James Bond's invisible car, where the light that comes in from one side gets bent around it and then comes out the other side, making the thing invisible. So scientists have achieved something like this for microwaves. Microwaves have a longer wavelength than visible light, and apparently achieving the same thing in the visible light spectrum is much harder, just because you basically have to like scale it all down to the much smaller wavelength and everything becomes more difficult. But something like this has been achieved. And so if gravity is an electromagnetic phenomenon, it might be possible, using some other advancement in metamaterials, to create some kind of gravity cloaking. I do think there's a potential fundamental problem in the maths with this, which is just that it's to do with the energy and whether you would actually fly away from the Earth if you cloaked yourself. And I'll explain why I've got this silly GIF here. So when this guy sat on the roof, he falls off the roof, and an enormous amount of energy is given out. So he gains a lot of kinetic energy as he comes off the roof, and that gets transferred into smashing up his carport and denting the car, and all that energy is released as sound and heat. So where did that energy come from? Well, it came from his gravitational potential energy. He's up on the roof, so he's got height, so he's got gravitational potential energy. But the question is, where is that energy stored? It's not stored in chemical energy. There's no battery. So where is his gravitational potential energy actually stored? Where does it live? And the answer is that it's in his mass. And this might seem odd, but if you take two masses and you have them some distance apart, they have more mass than they do when they're closer together. So when two objects come together due to gravity, they actually give up their mass, and that mass is transferred into the kinetic energy which they gain as they accelerate towards each other. And therefore, in order to get those two objects apart again, you have to give them kinetic energy, or you have to give them some kind of energy to go back into their mass. So back to our idea of just cloaking Roadrunner, I'm not sure that just by sticking a cloak around him, you would allow him to gain kinetic energy and fly off into space. because where would the energy come from? Now, you could say it comes from the fact that Roadrunner does have kinetic energy because he's spinning on the Earth, because the Earth is spinning. So I'm not convinced that it's wrong, but I'm also not convinced that it's right. Need to sit down and do some more thinking about that. So, type 2, is it possible to create some kind of repulsion anti-gravity? Is it possible to reverse the gravitational effect and make one object push another object away? And my answer is, I don't know, maybe. I don't really have any specific ideas about that. If you have any, let me know. But the third idea of swimming, which on the face of it seems more impossible because it would violate Newton's law of conservation of momentum, that if you make one thing go one way, something else has to go the other way. But somehow, weirdly, this sort of swimming concept appears to possibly have some more legs. Although I'm going to start in quite a weird place. This guy is called Bob Lazar, and he claims that back in the late 80s, he worked for the US government, reverse engineering an alien spacecraft that was held in a secret location south of Area 51. Now, that's obviously totally nuts. But I think that some of the ideas that he has are just like, I think it's like wonderful science fiction. I mean, it's possible that he's not lying, but just taking it as science fiction, I think it's really interesting. So he says that this alien spacecraft that he supposedly worked on is like a disc, like your classic flying saucer type thing, and that it creates a heart-shaped, sort of three-dimensional, more like donut-shaped, I guess, gravitational wave around it, so that it essentially sucks space in through the top and pushes it out through the bottom. So it's sort of bending space in a similar way to Einstein's bending space-time idea, that it's compressing the space above it and expanding the space below it. And then he says that it's got these three things which are spaced evenly in a circle, and that they can be sort of manipulated to either point in a slightly different direction or have different strengths to steer the craft where it wants to go. So that's totally bonkers. Oh, but he says some interesting things. He says that if you stand underneath the craft, you can't see it because the space bends around it, and therefore the light bends around it. He also says that this thing can accelerate at ridiculous speeds, and that therefore something odd must be happening, that if you were to accelerate at that speed, like in a car, you'd just get splattered against the wall. And therefore there has to be some kind of time dilation or space dilation inside the craft, such that the people inside it, or the aliens inside it, don't get splattered against the wall. And he also talks about it having waveguides somewhere, which he says look the same as like electromagnetic microwave waveguides. So anyway, that's nuts. But then in 1994, someone called Miguel Alcubierre, who I think he possibly did this for his physics PhD, he took the equations of general relativity and he took the sort of Star Wars idea of warp drive, and he actually came up with a set of valid equations for how you could create a way of bending the space in front of you, or rather, sorry, compressing the space in front of you and expanding the space behind you in order to move a spacecraft through space, which is oddly similar, but this guy was actually a physicist. So this is another diagram of the same thing. So it says it has this exotic matter ring, the sort of donut shape, and then your space rocket or spaceship inside, and that it expands the space at the back and it contracts the space at the front, causing this thing to move through space, and that it could actually allow you to move through space faster than the speed of light. And this is now like sort of well talked about, well known, and seems to be completely valid. It just has a couple of problems. The first problem is this, that this exotic matter ring requires exotic matter, which is, in other words, negative mass. That's not antimatter, because as we discussed earlier, antimatter is just normal matter but with the opposite charge, whereas this is actually negative mass, which doesn't exist. So that's the first problem. The second problem is that the quantity of exotic matter that he calculated that you would need is about the size of Jupiter. Might even be 2 Jupiters. It's a lot of it. It's like a vast quantity of exotic matter that we don't have, and that's not going to fit in a ring around your spacecraft. But somebody else has then picked this up a few years later and has somehow optimized it, and they worked out that you could achieve faster than light travel with only 700 kilograms of exotic matter, which doesn't exist. But I kind of find this idea interesting because although I'm sure that you can't have negative mass, I think that if the equations of general relativity are correct, but that there could be other fundamental reasons or other ways of arriving at those equations, then it wouldn't necessarily need exotic matter. Just needs a better understanding of exactly what is happening in gravity and finding a way of manipulating that or creating the reverse effect. This guy, Dr. Harold G. White, used to work at NASA. I think he's now moved on and created his own thing. But he spent a lot of time at NASA actively researching the possibilities of the Alcubierre drive and put serious time and effort into alternative means of propulsion, including this one. And he takes this entirely seriously, and people take him seriously. There's a YouTube link here, which is, I think, really interesting. And I think especially with the ideas I've covered in these talks, that video is just very interesting, hearing him talk about what they're exploring and how, and his thoughts on it. To give you a bit of an idea, he's trying to get around this problem of needing exotic matter by using something called the Casimir effect. So this is an effect where if you take two metal plates and you put them very close together, then you get a force between the two plates which attracts them. And this is actually weirdly similar to the shading effect theory of gravity that I covered in the previous talk. This idea that there are waves from all the particles in the universe in the ether all around us, and that when you put two objects into space, they actually shield the other object from those waves. But the Casimir effect is a well-known effect, and the sort of current theory is that it's to do with fluctuations in the quantum vacuum that causes this effect and causes the force between these plates. And so Dr. Harold White is looking at whether you can somehow harness that force to essentially, I guess, extract energy from the quantum vacuum and in some way use that to power the craft rather than trying to have negative mass. And again, I think that the Einstein idea of gravity may well be the correct equations for the wrong reason. And I think that if we look at all of this differently with a new perspective and an open mind, but not so open that your brain falls out, that there could be a way to manipulate gravity or space and create a new form of space travel. Conclusion? I don't know what my conclusion is. Oh yeah, the conclusion is that getting from Earth to Mars, I think, takes about 10 months on a spaceship, but getting to the next star out, which is Saturn, I think would take about 2,000 years. Sounds too much. I feel like I haven't got that right, but it's going to take a long time. Got some notes on this somewhere. Going to make sure I'm giving the right answers. What did I write down? Using nuclear electric propulsion, oh, it would take us 2 years to get to Saturn. Sorry, 2 years to get to Saturn, 2,000 years to reach Proxima Centauri, which is our next closest star. In other words, the distances in space are absolutely vast. And there's probably lots of interesting stuff out there. And if the human race is going to survive beyond the sun exploding, then we should find a way to go and explore it. And I think we should go and find a way to explore it anyway. And so I think this stuff is worth looking into. But maybe more importantly than that, people seem to love flying, and currently aeroplanes create huge amounts of carbon emissions, and we don't have a great way of making electric planes because the batteries are too heavy and it just doesn't work very well. And maybe rather than worrying about the sun exploding, we should worry about destroying our own planet and see if there is a way to make air travel that doesn't involve burning stuff. Here's a string of people from history. Galileo was considered totally crazy when he said that the Earth goes around the sun. Isaac Newton was considered crazy when he says that stuff doesn't fall because it's downwards, it falls because everything attracts everything else. James Clerk Maxwell was considered crazy because he said that light was just an electromagnetic wave. And then Einstein was considered a bit nuts because he said that space-time bends. But I think that whoever manages to figure out how to make stuff fly by manipulating gravity will also be considered nuts until they do it. The end.